The last team of this morning's session is team number 6, integrated irrigation.
So, as we all know, sustainability and conservation are two major topics of research and importance both at this university and around the world right now. And this project seeks to make an impact on these topics on a truly societal level. I'm Tim Wolf.
I'm Michael Barber.
I'm Yukon Choi. And we are integrated irrigation. So the problem as it stands right now for our customer and for anyone trying to maintain their private garden is that current gardening and watering methods are wasting water. They're inexact. We don't know exactly what's going on specifically for each of your gardening conditions at any given moment. You're kind of making a guess as to, well, it looks like it needs water, so you'll apply as much as it looks like you need at any given time. And this doesn't really help that much by an automatic sprinkler system, which doesn't even know by its timer, is it going to rain, is it watering while it's raining and wasting water. I've seen this at BU from the time. And wasting this much water because you're being imprecise is expensive. Water is a rapidly growing scarce. It's a resource that we're running out of, and as the population increases, it's only going to get worse. And finally, it's time consuming to manually have to go out and water your plants yourself. It's an extra chore, it's an extra thing you have to add on. It'd be nice if we can automate the process. So you need to consider this. The EPA estimates that 120 gallons of water are used outdoors daily by the average household. And 60 gallons of this is wasted, mostly due to imprecise usage in smart gardens. So, Mike will go over how we're going to fix this problem.
So our solution is to develop a computer-controlled irrigation system to minimize the amount of water wasted in the garden, while at the same time decreasing the amount of time and cost associated with water. Our system will first do this by integrating real-time information coming from the garden. Our garden will be broken up into 4 zones. Each of the 4 zones will consist of 1 sprinkler, which will be associated with that zone, as well as a sensor pack. Each sensor pack will consist of 4 modules: a soil moisture sensor, a thermometer, and a sunlight intensity sensor. This sensor pack will also contain solar panels and a battery pack to have the system run completely wirelessly. The 4th module within the sensor pack that we are utilizing is a Texas Instruments MSP430 wireless chip that will be responsible for sending all information coming from the sensors to our central computer. Now, once the information is sent from the garden, all the sensor readings are sent from the garden to the PC, the software integrates the real-time data coming from the garden along with a weather forecast for that day to develop the most optimum watering pattern for that day. The system also has complete control of each sprinkler attached to each zone, so the software is physically able to determine exactly how much, when, and for how long to water each particular zone. Now, also, the central server, or the central software that we have developed also has a unique feature in that it has a unique warning system where in the event of a flash flood or maybe a pipe leaks in your garden, the sensors will pick that up, forward the information onto your computer, and the computer software will either SMS text message the user or email them or both, letting them know about the problem. The second warning we've also implemented is a low voltage warning for the sensor packs. If the battery low voltage gets to be a bit too low, the warning will be sent to the user via text message or email. Also, we have a comprehensive user interface that the user can use to monitor the real-time status of the garden, everything from temperature values, soil moisture content, and temperature, as well as currently they can also display using lead graph DLL to display readings in the past. So this is a overview, top level of our system. Everything you see here in green is in the garden. Everything you see in red is in the home. So on the right-hand side, you can see these are the sensor packs that I discussed. Each sensor pack corresponds to 1 zone in the garden. Each zone also has an associated sprinkler and a valve that we will control to send water to that zone. We also have the sprinkler valve controller is a box of relays that will be used to send power to each of the valves to be controlled. On the right-hand side, we have what we have running in the home. There's a central computer software which is communicating to a central chip attached to the computer, another Texas Instruments MSP430. That chip will communicate with our zone relay controller to first provide water to the garden. Our ECE system is unique in that it's a two-stage system. We must first supply water to the garden. And then once water is supplied, we can then individually toggle the valves to supply water to the zone. The zones are all controlled via a 24-volt AC line that, as I said before, is controlled by the zone relay controller, which is controlled by the wireless chip. Also, we have a range center in the center. The garden is too far away from the home to have the sensor chip communicate directly with the sensors in the garden, so we utilize the range center developed by UFON that is essentially the middleman and it sends data to and from the garden and ECE.
So to make this system work, I also need to have real-time data. We do this, as we said, through these analog sensors that are all bundled into individual packs, one pack per zone. They can measure moisture, temperature, or sunlight. All these analog sensors are fast in terms of gaining their data. They're very stable in the signal they put out, and also very accurate in terms of what they're actually measuring in the physical world. And they communicate well with the MSB 430. These boxes, these packs, are designed to survive the elements. They will be able to withstand sitting outside. The casing that you see here is very weather resistant and durable, and it's been sealed up with multiple different methods to prevent any moisture from entering, and to prevent the elements or any animals from damaging it as it's in the garden. It's important to remember here is that these all transmit their data wirelessly. There's not going to be wires running throughout the garden. So this is made possible by those sensors you see clustered there by the chip, being able to convert the analog values to digital values accurately, and then have those digital values transmitted wirelessly over the network, courtesy of the chip. So I'm going to talk to how we power these.
Now, as said before, these power packs are powered by solar panels. So we have 6 polycrystalline solar panels that are on the roof of these solar packs that power 3 nickel metal hydride batteries. Together, these 3 nickel metal hydride batteries will last a total of up to 2 weeks without sun. That's if something happens to block out the sun for an entire 2 weeks. So essentially, the user won't ever have to replace the battery unless that happens, or if the batteries become faulty over time, they deteriorate. The whole powering system is moderated by onboard chip that will turn on and off the charging power depending on the voltages that it displays, so that we won't overcharge, we won't damage these batteries. Overall, our solar panels delivers 4 volt 115 milliamp power flow, but this equivocates to about 2 days of fully charging the batteries from the time when we start charging to when we stop charging it. Yep.
So, obviously, I'm pretty sure none of you want to have live wires running throughout your garden, and thus we decided to to implement a wireless network. So we decided to use the star topology centralized around the main controller, which is this red node right here. And basically, all the information will be forwarded to the main controller, which will then be forwarded to the computer. Now, the MSB 430s are low-power devices, and thus the range is limited. We tested that in line of sight range, it can transmit up to 150 feet. However, under normal circumstances, you would have at least the wall of the house blocking the line of sight. And throughout testing, that range is not sufficient, and thus we have to implement a repeater, which is this orange node right here. And while it's not obvious, it may not be obvious that there's a star topology, the only function that the repeater offers is to forward messages between the nodes. And thus, so for example, you would have the wireless sensor packs, which are these 3 nodes. They would sample the sensors and then transmit the results to the repeater, who then forwards it to the main controller. So essentially, the repeater is somewhat transparent because in the end, it's just basically these nodes transmitting directly to the main controller. And then the main controller would process the information and then transmit the information to the computer via USB. Some information about the wireless protocol that we're using. The MSB 430 utilizes the Simplicity protocol, which is basically Texas Instruments' proprietary wireless protocol. It follows the IEEE 802.15.4 standard, which is the same standard that Zigbee uses. for those of you who are familiar with Zigbee. This protocol also offers a few security features. However, it is not really relevant to our project unless your neighbor might be planning to sabotage your garden. In which case, you call that bigger issue to deal with than your garden. So we also implemented an acknowledgement system where any of these nodes that transmit to the main controller would receive a reply saying basically, I received your message. This allows us to determine, this allows any of the other devices to determine if the main controller is still powered. And if it's not, then obviously you would have multiple messages that are unacknowledged. And then they would try to reconnect to the network when you power up this main controller again. This might happen when the user accidentally unplugs it or maybe shut down the computer. There are quite a few situations where this can happen, and thus we implement this acknowledgement system. So whenever the user plugs it back in, the network would return to its normal functionality.
So now that we've received the data from the garden, we also need to access the weather forecast. We do this via a web API provided by Weather Underground, also known as Wonderground. And they provide us an XML with our data. And the XML is this, a lot of this. Essentially what we do is we parse through this to create something more visually pleasing. This is our the main screen of our user interface. And here you can see that we parse through this file and display the today's forecast is like a high and low temperatures, our conditions, our chance of rain, sunrise and sunset. And now that our system has all this data, well, what do we do with it? As we receive data from the garden, we write them, we record them in a CSV file. Our central control accesses the CSV file and does calculations on the data read. And what we want to know is the decrease in moisture over time. And so here's an example of what it records. So say over an hour at a certain temperature, say maybe 68 or 69 degrees, over 1 hour your moisture decreased at 1%. So now that we have our forecast, if today it's going to be 70 degrees, we know that our moisture is going to go down 1%, and we need to water that much more in the garden. Lastly, what it does is it makes sure that the conditions of the gardens aren't. We have to make sure that it's not too hot or too sunny outside, or that it's not actually raining outside before we can actually garden. So if it's actually raining, then it doesn't need to go in.
So as Tracy showed a couple slides ago, the screenshot with the weather forecast is actually our main, the home page of our user interface, but this zone information tab is actually the secondary screen in our user interface. The user, all he or she needs to do is simply click on either of or one of the 4 zones, and it'll display that current soil moisture percentage, current temperature, ethanol intensity, along with the plants growing in that zone. The plants provide no performance or do not change functionality at all. It's just as a reminder for the users so they know what plants are growing in that garden. So, as I just mentioned, it provides useful zone information. It also provides helpful live weather updates, which are described by Tracy in the previous slides. It also has any graphic capability that allows the user to go back in time and pick a date range of given readings, and it'll display with a line graph either moisture, temperature, or sunlight readings. There's a system monitor and a customizable settings form that I will go to describe in the next slide. Here we have 2 screenshots of what I just mentioned, the system status over on the right and the settings form on the left. The user has the ability to enter his or her phone number, his or her provider, as well as an email address. They can enable or disable whether they want their warnings to be sent to them via email or text message or both. Also, as a note, we have to provide the, you may ask why carrier. Every carrier has a unique SMS server that is used to handle text messages, so we do need to have users select this information. We also need users to request or to input their zip code, because in order to give you an forecast, our algorithm won't work unless you those zones. It does analyze the data coming in real time from the garden, and it will tell you whether that sensor or the sensor in that zone is online or offline, as well as the battery indicator of that particular path. So maybe the user doesn't want to wait to get a low battery warning, maybe he wants to be proactive ahead of time to change the battery themselves, so they can just open up this form, check and see, okay, everything's kosher, everything's running, and the battery voltage is good. So, as a whole, our project aims to decrease the amount of time, the amount of money, the amount of effort required in watering the garden, as well as decreasing the amount of water wasted. Our customers' current setup is tedious, time consuming. Use a simple timer that isn't very effective. Research shows that upwards of 50% of all water is wasted in the garden. Our system provides robust timing algorithm, real-time data sensing, automated watering, any sort of issues with watering. If you have to sit there for 15 or 20 minutes watering, you don't have to do that. The system will do it for you. It's very efficient. We have calculated that upwards of 50% water can be saved. User essentially, this is a plug-and-play system. User plugs it in. It will monitor the soil conditions, integrate those conditions via forecast, and will pretty much negate the user from the gardening. In theory, only using them for handling any sort of issue with the garden. So, that's our project. Any questions?
I understand you have multiple sensors, right, in your system?
Correct. One sensor per zone. One
So
sensor pack.
So if they get conflicting reports, so do you care, or do you look just at one each individually, or do you look at aggregation of all what they tell you?
Well, the whole idea of having multiple sensors is the garden right now isn't very level, so the water distribution or the water runoff is different in each zone. So it is possible to have vastly different readings coming from each zone. For example, there are trees in the customer's backyard. It's very possible that half of the garden is in shade and half of the garden isn't. So the portion that's in shade will be much cooler and would have a higher moisture content because it wouldn't have evaporated, whereas the portion of the garden in the sun should be warmer and therefore have less moisture content. So we do account for massive fluctuations. If one zone is saying it's 100 degrees and one zone is saying 20, there's clearly an issue there. But if there is a change of a few degrees or a few percentages in moisture content, that's to be.
So it actually helps with that we all model our garden, and I guess that they're uniform, but in reality, you have different zones that can move the moisture differently. That moisture might pull up in one end more than the other, one might get more sun than the other, and different plants have different conditions. So when the gardener knows exactly kind of the contour of the garden in terms of moisture, temperature, sunlight, they're able to select what plants can go where more precisely.
Yeah, maybe a security-related question. You're not with the diabolical neighbor, but suppose your neighbor is equally enthusiastic about a smart gardening system and installs their own. Do they tell each other apart, or would they be
So-
not into each other, or what?
So basically, every network has its own link and join token. So as long as those tokens are different, then they'll be different networks.
A couple questions. One is, what that pay electric moisture, and the other one is, if you had to sell this, what would be a typical off-the-shelf cost?
The sensors that we use are designed to, I believe they're 9 inches long. 6 inches
We
long.
have 6 inches big. And in terms of cost, right now we market just the 4 sensors, the computer system and the relays. That's around $600.
Also, the cost would be decreased because with our current setup, we don't use PCBs, so we have to buy individual dead boards, which are $20 for the chip. So if we were to do PCBs, the cost would be dramatic.
So is the computer a requirement, or can this thing run on its own, just a little controller, keeping track of whatever you set it to, or do you need an active PC?
No, we need an active PC. There isn't nearly enough computing power on the chip that we use. All we use the chips for, essentially, is to relay the information from the garden over. PC is the brains. We use the software to go to the web to get the forecast. We use the PC for the
running as a single application PC.
Correct.
So how easy would it be for you to re-architect your system so that this could run on an iPhone or a mobile app? Is your UI and your data processing all the same?
Right, it's all in the same application. We haven't looked into it much. We know that a lot of the application of the Apple devices run on open C#, not open C#, C, Objective-C, Objective-C, which is entirely different structure. They're developed ours in C# and .NET, so I'm sure it's possible. We haven't looked into it.
I saw in your Google display that you had a selection of which plants you have in the garden. You have different models for what amount of moisture or conditions you can plants on?
No, as I said, it doesn't, telling or inputting what type of plants are growing doesn't affect the performance at all. That would be, going forward, that would be useful. We just have those there just as a reminder. The user can go into the settings and just say, I have this one going on, this one's on too.
Okay, so there's a goal moisture for you.
Right, exactly, which the user decides. Also, one of our problems was the system has no way of knowing how well it's doing. If plants die, it doesn't know. So you set the system to say, I want to hold zone 4, 3, 4% soil moisture. If that happens to be too high, the system has no way of knowing that. So that's why we give users the ability to manually go in and tweak the content to see fit, to see how plants are reacting.
Can you compare this to another system to see how much water you're saving?
To be honest, there aren't any other systems like this that work for the home garden. There are
Just the normal, regular watering every so often.
no,
Like
we
you
haven't
guys.
had the chance because unless we cannot know how much water we're saving until we figure out exactly like what the flow rates are, the sprinkler, along with the time of watering. We can do that once we get to the home. We can measure the flow rate, and then once we have the flow rate, we have the time of watering. We can calculate that. But without doing so, all we can do right now is do the control in terms of analyzing the amount of water saved. That will need to be done on site over the course of several weeks.
Very reason why it was limited up to 4 sensitive.
No, there's no particular reason. We just chose 4 because the garden does well for 4 zones and has 4 sprinklers. But this could easily be scalable to up to like upwards at least 40 if need be. But the range might be a little limited in that case if you're getting standard.
Did you make any effort towards compatibility with standard controllers, valves, plumbing, and so forth that's available to the home gardener?
Well, all of our controls do toggle a 24-volt AC line, which is, I believe, the standard in most home gardening. All valves run on that. Yeah. As far as integrating with unique hardware, we bought our own valves. There are no valves in the garden right now. It's just when you turn the current setup is when we provide water to the garden zone, all 4 sprinklers turn on.